Civil engineers who work on site plans, what we also call meets and bounds drawing, use different kinds of units. And let me show you how we can access the units command. I can either go to the big A, which is the applications manager. I can go to drawing utilities and choose units. Or I can go up to format and choose units. Or what I can do is I can just type the command units. When you look at the interface box, you'll see that the standard units that we have been using are architectural, and our precision has been set to 1/256. What civil engineers do is they choose decimal units. Okay, for us, an architectural unit is 1 inch. For them, a decimal unit represents a foot. So they would have decimal units, and then we have the precision. Normally, the civil engineers present their units to 2 levels of accuracy. So where the units are decimal, and 1 decimal unit would represent a foot, and then you can see with the precision going to hundredths, that means hundredths of a foot. That's how they are interpreting their units. Then we have the angle type, and this is what we're going to focus on the most right now. Their angle type are surveyor's units, and their precision is normally, just like ours, north, so many degrees, so many minutes, so many seconds, and the example they're using here is east. So again, we have set our units on a civil engineering drawing to be decimal. So the type of unit is a decimal, where again, 1 decimal unit represents a foot. The precision is 2 hundredths of a unit, and again, they're interpreting this to be hundredths of a foot. The unit types they use are surveyor's units, and I'm going to go OK. Now, I have a site right here that's relatively simple, and the site is a rectangle, just so we can begin understanding what's happening. When surveyors begin doing their work, they start off with something called a point of beginning, or POB. And what they do is they work their way around a property. So these arrows are representing the order in which the surveyor, in this particular example, would be measuring the length and direction of the property line. They would start off at a point of beginning. They would go up, measure to here, go this way, measure to there, go down here, measure to there, and then come back and close it at their point of beginning. Now, when I look at the line segment that is going this way, this segment is going north so many degrees towards east or towards west. Because typically, when engineers are doing their work, they're saying north so many degrees towards east, north so many degrees towards west, or south so many degrees towards east, or south so many degrees towards west. So in this example we have right here, we're going from the point of beginning north 0 degrees towards east, and that will get us to this point. To continue on, they would be going, in this example, north 90 degrees towards east, which would take us over here. From here going down, they would be going south 0 degrees towards either west or east. And to continue on, they would go from here to the left, which would be south 90 degrees towards west. So this is a very simple example based on a rectangle that is perfectly north and south. You know as well as I do, though, that most properties don't go straight up and down, north and south, left and right, east and west. Normally, they will be relative to different angles. So now I have taken this very same property and I've rotated it 30 degrees. So let's zoom in. I have my point of beginning, and again, what we're doing in this example is we're going clockwise. So we're going clockwise around the property. So if the surveyor starts at the point of beginning, and again, everything in this example is rotated 30 degrees, to go from my point of beginning to my point up here, I'm going to be going in the direction of north 60 degrees towards west. Because again, when you look at the compass, you can see that this line segment is in the top left quadrant, and it's going north 60 degrees towards west. If I pan over to here, this next segment is going north 30 degrees towards east. So that this segment right here is going north 30 degrees towards east. I'm continuing in the same direction. For this next segment, I'm going south 60 degrees towards east. So again, this segment here is in the bottom right quadrant, so it's south 60 degrees towards east. I continue on. This next segment is in the bottom left corner, so it's going to be going south 30 degrees towards west, and it's ending up at the point of beginning. Whenever we do meets and bounds drawings, we do not do a C to close. What we want to know is that if the property lines do not close, we need to find out what the problem was. So again, we would not draw 3 segments and then go C to close. We would always want to have this last segment with its own appropriate distances and directions, and if there is a gap down here in the bottom, we need to know about it. What I've just done is I've turned on some layers that's showing going the opposite way. Now, everything we've been showing so far is their path of travel has been in a clockwise direction. I want to show you instead going in a counterclockwise direction. So if I start at my point of beginning, you can see here by going in this direction that I'm going to be going north 30 degrees towards east. Now let me just pan back a bit. When I was coming the other way, this line segment was measured south 30 degrees towards west. So I was going south 30 degrees towards west. Whereas when I'm going counterclockwise, it's north 30 degrees towards east. I will continue on. This segment here is in the top left quadrant, so it would be north 60 degrees towards west. This segment down here would be south 30 degrees towards west. And this last segment would be south 30 degrees towards east. So again, what I'm hoping you can see is that when I have a segment that's going clockwise, this segment would be north 30 degrees towards east, whereas the same segment being measured the opposite way would be south 30 degrees towards west. So hopefully this has begun to give you a general overview